Now in these examples, in this set of examples, they're asking me to determine the sine or the cosine equation that corresponds to the given graph. And this is example number 1. So the given graph, just by looking at the shape of it, I can determine that it is a sine function. It begins, remember that sine functions always begin at the average y value and end at the average y value. It's the shape of a sine function. So that means that to start with, my equation is going to be in the form y is equal to a sine of bx plus c plus d. Okay, so from the graph, the given graph is from where I'm going to be getting all of these elements that will complete my equation. So first, I will determine the amplitude. The first thing that I will determine is the amplitude. Remember that the amplitude is the coefficient of the function, the sine or the cosine function. So the first thing that I'm going to do is enclose my graph in the box that we were using to determine in the previous examples. I'm going to be using the box again. So I enclose my graph in that box, okay? So in order to get the amplitude, the first thing that I have to locate is the average y value. In this case, the average y value in this graph, the average y value is exactly at the x-axis. So that means that the graph is having no vertical movement. This means that for this particular case, since the average y value is on the x-axis, I will not write the plus d part in my equation. You know that the amplitude is counted above and below the average y value. So in this case, I count the units that I have, which is 1, 2, and 3 above, and 1, 2, and 3 below the average y value. And that is going to be my amplitude. So for this case, I can start saying that y, I'm sorry, this one is not working. I can say that y is equal to 3 sine something of x plus something. And since I don't have vertical movement, I will not consider this the value. Remember that we stated that the average y value of the box, or the middle of the total y extension of the graph, is exactly at the x-axis. If you count, you will have 1, 2, 3, 4, 5, 6. So half of it is 3, that would be your amplitude. Okay, which is what I stated here, amplitude of 3. So, continuing with that, I need to get the b that is going to multiply the parentheses. How do I get that? The b is obtained from the period. So the period for this function, or for this graph, the period, okay, I am going to count, and before I start counting, let's notice that your graph is, I'm sorry, this is a 4, not a 2. Okay, I notice that my graph is split in quarters. 1 quarter from here to here, 2 quarters, 3 quarters, 4 quarters. Look at the denominators that you have in the scale of the graph. Minus 3 pi over 4, minus pi over 4. I'm sorry, this is going to be 2. Sorry, there's a mistake also there. Minus 2 pi over 4, which is equal to minus pi over 2, 1 pi over 4. So I have 1/4, 2/4, 3/4, 4/4. Okay? So my period in this case, then I can say that is 4 pi over 4, which is equal to pi. Your period is of 1 pi. Okay? So for that you have to check the denominators that they are giving you in your scale. Okay? So from the period, I remember that the formula for period is 2 pi over b. The formula for period is 2 pi over b. So from there is from where I'm going to get the b value. It will be pi is equal to 2 pi over b. So this means that b is equal to 2 pi over pi. 2 pi over pi, which is equal to 2. So that b value is going to be 2. That is written outside of the parentheses. Remember that at first I have to write it out of the parentheses and then determine the horizontal movement and the FOIL, as we did in the examples from yesterday. So, now the horizontal movement. Let's remember that the original graph of the sine function begins at 0, begins at the origin. So by looking at this graph from the origin, the graph is shifted pi over 4 units to the left. Again, the graph is shifted, the beginning of the graph, if I compare it to the original graph of the sine function, that begins at the origin is shifted minus pi over 4 units to the left. So that means that if it is to the left, my sign is going to be plus pi over 4, okay? Since I have no vertical movement, again, I do not consider the d part. That is not going to be considered in the equation. I don't need to write it down. Or if you wish to write it down, it would be a plus 0 that you don't have to include. From there, the last thing that I have to do in order to finish getting the equation is FOIL in the parentheses. So I will have y is equal to 3 sine of 2x plus 2 pi over 4. And from there, I can also write my equation as y is equal to 3 sine of 2x plus pi over 2. And also, y is equal as 3 sine of 2x plus pi over 4. Any of both is correct. Just be careful with the multiple choice questions in the exams. Okay, just to emphasize, this is a 4. Just to make it clear. Okay. I was missing the sine word, and this is divided by 4. Okay, so any of both ways is correct. That's the complete example. Okay, let's move over to example number 2. Example number 2, they're asking exactly the same thing to determine the sine or the cosine equation that corresponds to the given graph. In this case, by looking at the shape of the graph, I can say that it's a cosine function, okay? But the thing is that it's not a regular cosine function. This one is reflected over the average y value. Remember that cosine functions, the basic shape of a cosine function is going to be like this. Okay, it's an N or a U shaped. This would be y is equal to cosine of x. But, okay, in the given example, the graph is the other way around, so it means that this graph has a reflection over the average y value or over the x-axis. So I have determined that it is a cosine function, so my equation is going to be y is equal to something cosine of bx plus c plus d. Okay, so that's the equation that I'm going to be getting. So the first thing that I have to do is remember that I will use the box in order to determine the elements. The box is from bottom to top and from beginning to end. Okay, that will be the box. So the first thing that I have to get is the average y value. In this case, I will have to count the whole y extension of the graph, 1, 2, 3, 4. So that means half of 4 is a 2. This means that my average y value is right there. I have to split it exactly in half. So I notice that from the average y value, I go 1, 2 units up and 1, 2 units down. That means that my amplitude in this case is going to be 2. So I can say that the equation will start looking like y is equal to 2, but since the graph is reflected over the average y value, this means that my amplitude is going to be negative. Minus 2 cosine of something x something and the plus d. Okay, let's get the horizontal movement out of the way, the plus d part. I already noticed that the average y value is shifted 1 unit down from the x-axis. So that means that the graph is shifted 1 unit down. Again, the average y value is shifted 1 unit down from the x-axis. Average y value of the original one, which was at the x-axis, is shifted down 1 unit from it. So that means that my average y value is now at y is equal to minus 1. So that means that I am having a vertical movement of 1 unit down with the vertical shift. From there, I need to determine the period. Okay, and for that I need to check the scale of the graph. If you notice in this graph, I am going minus pi over 4, 0, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Okay, so this means that again my graph is split in quarters. So I have 1 quarter, 2 quarters, 3 quarters, 4 quarters. Okay, so my period over here, my period is equal to 4 pi over 4, which is equal to pi. So my period is again pi. This means that period, which is pi, is equal to 2 pi over b, because I need the b value and I solve for b. B is equal to 2 pi over pi. I cancel the pi's. And again, in this particular case, my b is 2. Okay, so let's remember that I write out that outside of the parentheses. Okay, let's remember. The original graph of the cosine function begins at the y-axis. In this case, the graph is also beginning, even if it's reflected, its horizontal extension is beginning at the y-axis. So this means that this graph has no shift in the horizontal direction. It has no horizontal movement, no phase shift, okay? So how will I express that? As a plus 0. Okay, that is going to be expressed as a plus 0 in my equation. So once that I have all of the elements, what I finish doing is just doing FOIL with the 2. The 0 doesn't need to be written down. So y will be equal to negative 2 cosine of 2x minus 1. And that's my final equation.